Sometimes we need a section of memory allocated that is completely clear of any data inside of it. To do that, we're going to need to create a calloc function, which, if I'm correct, it stands for clear allocate. So let's get started with our header declaration. So just like with malloc, we'll do a void pointer calloc uint 64 size with a semicolon, and we'll collapse all of these just to make it seem a little bit nicer, and then we'll make our function declaration. The first thing we need to do is get the value returned by a malloc call, so we can do malloc value equals malloc size, and then return malloc val. But we haven't cleared it yet, so we could actually go through from the beginning address of malloc val through to the beginning address plus the size and set them all to 0. But there is a better way to do that, and the better way we can do that is to make it some optimized memory set functions. The one which we're going to be using here is memset. So let's create a new CPP and header combination, and we'll call it memory.cpp and memory.h. So we'll create memory.cpp, and we'll start off by include memory.h. We haven't made it yet, but we'll make that in a second, and create our new header file, and it will be called memory.h. Now inside of compile.bat and link.ld, we need to add memory to our compiler. So memory.o in the linker, and memory.cpp and memory.o in the compiler. Alright, so in memory.h, let's declare a function. Let's call it void memset, and memset takes a start location as an address pointer, a value, and a number. So we'll do void pointer start, uint 64, which we need to include typedefs.cpp for this, typedefs.h I should say. So we have uint 64 value. This is a value that we're going to be putting into all of the memory locations throughout memset, and we need to do a uint 64 num, which is basically the size of the address block that we're going to be setting to value. Now we can copy this into memory.cpp and actually create our function. For some reason, Visual Studio isn't resolving these identifiers, so I'm just going to include typedefs.h inside of memory.cpp, but you probably don't need to do this since it's defined in memory.h. Alright, now on to designing our memset function. Now we could just iterate through the entire address and set it 8 bits at a time, but that's going to be extremely slow. So what we're going to do is fill in as much as we can with a 64-bit value, and then fill in the rest with 8-bit values. Eventually we'll be able to use extension sets for the CPUs to take advantage of like 128-bit or 256 or even 512-bit operations to speed things up substantially, but for now we're just going to be using 64-bit. Alright, so now we need to make sure it can handle the case where we are only memsetting less than or equal to 8 bytes. So if num is less than or equal to 8, we can declare a uint 8 pointer val pointer equals uint 8 pointer ampersand to generate the address of value, so ampersand value. So what we're doing is getting a 8-bit pointer to a 64-bit value so that we can just use some of it. So now we can do for uint 8 pointer ptr for pointer equals uint 8 pointer start. So we're just setting a pointer to the start address. Pointer less than uint 8 pointer 2 brackets uint 64 start plus num semicolon. So while pointer is less than the start address plus the size of the memset, pointer plus plus. So now the value at pointer equals the value at value pointer, and we can increment value pointer. So obviously if we have less than 8 bytes we have to allocate, then we can't use a 64-bit operation because that will just use 8 bytes at a time. So we need to do it byte by byte. Well, so that's out of the way. So if it's less than or equal to 8, we do that. And then we can return. Now we need to handle the situation where it's more than 8 bytes. So we declare a uint64 preceding bytes. And this equals number modulo 8. So this just lets us know how many bytes are after the amount of bytes that we can do with a 64-bit operation. And then we can do uint64 new num equals num take preceding bytes. This just lets us know how many 64-bit operations we can do. Now to iterate through and actually set the memory, we can do for uint64 pointer equals uint64 pointer start. So it's similar to what we were doing before. So while pointer is less than, we can basically just copy this. So while pointer is less than uint64 pointer start plus new num pointer plus plus, the value of pointer now equals value. Now we need to deal with the preceding bytes, which are the bytes that we haven't set yet. We'll just do those similar to how we set the bytes in the beginning. We just need to do uint 8 val pointer equals uint 8 reference value for uint 8 pointer equals uint 8. So basically this value here, what we had up the top, so uint 8 of start plus num, except now it is new num instead of num, pointer less than uint 8 start plus num, pointer plus plus, the value of pointer equals the value of val pointer plus plus. So basically what we're doing is, if we have less than 8 bytes or equal to 8 bytes, we do it a single byte at a time. Or else we find out how many 64-bit operations we can do, and then do those, and then finish off with the single byte operations. That's it for the memset function. Now, back in our heap.cpp, we can finish our calloc function. We just need to include memory.h inside of heap.h, and then we can do memset malloc value, set it to 0, so all of the values are set to 0, and size. So now everything inside of this malloc block will be set to 0. So basically we've done a calloc. So also, before we finish up, we need to do another calloc function, which is uint64 num and uint64 size. So basically this just allocates a number of things. So basically it's num times size, if that makes sense. So basically we can just return our first calloc function, so return calloc num times size. And this is useful for if you want to declare an array of things. You can just enter the amount of objects you have and the size of them.